Alright, so here's some help with the thermodynamics lab. So for the first pre-lab, you have to look at the standard enthalpies. In the reactants, we have ammonium chloride. In the products, we have both ammonium and chloride ions. So you'll take those values and you'll write them over here. Okay, so for ammonium, we have negative 315.4. For ammonium ion, we have negative 132.8 kilojoules. And for chloride, we have negative 167.4 kilojoules. So it's important to remember for the value of H here. So AH is equal to Q of products minus the Q of reactants. Right? So if we think about that, oops. Since I'm going to have to subtract it, right? So this minus a negative, so this becomes a positive, right? So if I do that reaction, I get 15.2 kilojoules per mole, and that's going to be your Q actual, right? So this is what we're going to use at the end for a percent error, right? Okay. Alright, so we come down here. First thing I need to do is fill out my data table. So for I'm going to make my density 1 because it's significant. When I run a significant digit, it's going to be 1 anyway. So my mass of my water is 45.0 grams. Right. My molar mass of my salt, when I calculated it out, was 53.50 grams. When I did my mass to mole, right, I simply divided these two, get 0.0936 moles. So my mass of my solution is going to be my water plus my salt. So I get 50.50 grams. Actually just 50.5 because of here, so I'll keep it into significant digits for you. My final minus my initial temp, I get negative 7.4 Celsius. And then I'll calculate these other ones later. So that's the chart. I realize I'm missing question number 1. Alright, so I'll do question number 1 first. I want to ask you for the Q of the reaction. I'm going to keep Q is equal to MCT. I lost my pen here. MCT. So Q is equal to mass of my solution. That was 50.0 grams. C is my 4.1 paid for joules per gram Celsius. And my change in temperature is negative 7.4 Celsius. Right, so if I get this, I get 1550 joules, or negative 1550 joules. Okay, so for 2 here, right, it asks for kilojoules per mole. So I've got negative 1550 joules. My moles were 0.0936. I need to go to kilojoules. there's 1,000 joules and a kilojoule. All right, so if you think about it, I can get rid of this 1,000 and just move my decimal point right there. All right, when I do this, I get negative 6.6 kilojoules. All right, so before we continue on here, so this is Q of the reaction is equal to negative 6.6. Right? Actually, this isn't Q of the reaction. This is Q of my experiment. Right? So this is the calorimeter. That's my calorimeter Q. Kilojoules per mole is equal to 16.6 kilojoules. And this would be my Q of my reaction. Right? Because remember that we talked about, so we talked about that the Q of the calorimeter is equal to negative Q of the reaction. Right? So I have to change the sign here. So this one right here is going to be the one you have to use for your percent error. So we come down to percent error. Remember I have actual. Oops. Oh, that got all messed up, didn't it? I lost it. Alright, we're just going to have to assign this here. So it's going to be actual minus experimental divided by actual. And I'm going to have to make that an absolute value. Alright, so for my actual, I had 15.2 kilojoules per mole. And that was from the pre-lab. I'm going to subtract my experimental, 16.6 kilojoules per mole. I'm going to divide that by my experimental and my actual again, which is 15.2 kilojoules per mole. And that's going to give me 0.0921 or 9.21%. So when you do this, you might get a negative number, but remember that this was an absolute value. Right? So if it comes out negative, I have to make it positive because it's just the absolute difference. Right? So that's the answer for that. All right. Okay, so I hope that helps you, and good luck.